Let's look at our notes that I just handed out. And also look at the empirical rule that I gave y'all yesterday. So this was dealing with standard deviation. So X represents the mean, S represents the sample deviation, and this is all with our sample. Standard deviation, sorry. And remember our usual values? The usual values are between X minus 2 standard deviations and X plus 2 standard deviations. So this is called your min usual and your max usual. So we use min usual and max usual to figure out the outliers, like if we have certain outliers. And we're going to use that even more today. So this is really helpful to keep throughout the semester. We'll be looking back at it. All right, so let's look at measures of relative standing. 3.3. So a z-score is the number of standard deviations a given X value is above or below the mean. So relative standing, we're talking about the position relative to our mean. So it can be above the mean or below the mean. So if we look here, if your X value is right at the mean, it's 0 units away from your mean. So your z-score right here would be 0. Your z-score here would be it's 1 standard deviation above the mean, so your z-score would be a 1 here. So what do you think it would be here? How many standard deviations is it above the mean? 2, so your z-score would be a 2 here and a 3 here. So we can actually find out how many standard deviations a value that's right here is. So of course it'd be between 0 and 1. Then the negative just means it's below. So the value that's right here in relation to our mean is going to be -1. The z-score would be -1 because it's -1 standard deviations. It's down 1. So then this would be -2 standard deviations and -3. So that's what our z-score represents. It represents its position in relation to your mean. So here's the formula for it. You take your X value that you're given, subtract the mean from it, and then divide by your standard deviation. Not too bad. Okay, this is for your population, so it's the same thing. Your value minus your population mean divided by your population standard deviation. It's used to compare values from different data sets. Whenever a value is less than the mean, its z-score is negative. So that's what I was talking about over here. Anytime it's below, our z-score is going to be -1 here, -2, -3 because it's below. Z-scores describe the location of a value in terms of standard deviations relative to the mean. So our standard deviation is kind of like our unit. Instead of saying I'm 5 centimeters away, it's saying I'm 5 standard deviations away or whatever. It's kind of like your units. So ordinary or usual values have z-scores. Remember how I said, here's your usual values? What would your z-scores have to be between? -2 and +2. Because our max usual is plus 2 standard deviations. Our min usual is minus 2 standard deviations. Unusual values have z-scores beyond -2 and 2. So we're saying smaller than -2, but greater than 2. We round z-scores to 2 decimal places, and we express them with no units of measure. We just say z equals whatever. We don't write a unit of measure. And so here, zero z-score would be right on your mean. So we have between -2 and 2, those are your ordinary values. Anything beyond that would be our unusual. So anything that lies in this area would be considered an outlier. Same thing here. Anything that lies within this area is an outlier. Example 1. With a height of 67 inches, William McKinley was the shortest president of the past century. The presidents of the past century have a mean height of 71.5 inches and a standard deviation of 2.1 inches. What is the difference between McKinley's height and the mean height of presidents from the past century? So if we were to line up our data, you'd line it up from least to greatest, you'd find your mean, then you'd find out your standard deviation. They've already given that to us. So we can say our mean is 71.5. Or actually, let's use our X bar because it doesn't say it's the population, so we're saying it's a sample. So X bar is 71.5. And then our standard deviation, the little s, is 2.1. So the first bullet, all it asks us for is the difference. So we will subtract 71.5 minus 67. So how much smaller was he? How much shorter was he than the mean? It's 4.5 inches. How many standard deviations is that? The difference in his height from the mean. So if we have 4.5, a standard deviation is 2.1. About how many standard deviations is that? If I do 2.1 plus 2.1, that's 2 standard deviations. That's only at 4.2. So I'm going to write more than 2. We can actually find what it is by using the formula for the z-score. So we would take our value that we're given. This is our x value. That's the data value. So 67, I'm going to put z equals 67 minus the mean height, 71.5, then divide by our standard deviation, 2.1. And we can put that directly in the calculator. Okay, so it comes out to negative 2.14 when we round it. Do y'all agree? Okay. So that means it is below the mean by negative 2.14 standard deviations. So on here, it would fall in the unusual values. It would fall over here. Okay, if we consider usual heights to be those that convert z-scores between -2, I didn't kind of carry over, and 2, is McKinley's height usual or unusual? His height is unusual. So he's unusually short compared to other presidents. Let's look at the second example. Let's talk about the IQ test. Has a mean of 100, standard deviation of 15. Psychologist tests a woman's IQ and finds that it is 121. So our X value is 121. And our IQ has a mean, so it's X bar, it's 100 with a standard deviation S of 15. So plug in what we have. So our z-score is going to be 121 minus 100 divided by standard deviation of 15. And that comes out to 1.4. So this is between the -2 and the +2. So it is considered usual. Q is usual. Quantiles or fractiles? Quantiles is breaking data into quarters. And quarters means it's 4 groups. So quantiles divides a set of data into 4 groups with roughly the same number of values in each group. The median is our middle value whenever you list them in order from least to greatest. So whenever you have your median, that's right dead center. So 50% of the values are equal to or less than the median, and then 50% are equal to or greater. And then we have quartiles. So we have our first quartile. At least 25% of the sorted values are less than or equal to Q1. And at least 75% of the values are greater than or equal to Q1. So whenever you think about quartiles, you're cutting it into groups of 4. So if I have my data right here, I'm going to cut it into groups of 4 that have roughly the same in each. Which you can see mine is not very equal, but you get the idea, right? So if I cut it into equals, this right here is called your median. That's your middle. So 50% are at or below it. 50% are at or above it. And so since they're quartiles, 25% is in each one of these boxes of the data. And you have to list them in order from least to greatest. So quartile 1 would be everything from your smallest value to quartile 1. So this is Q1. And this is your smallest value. Then your median is actually Q2. So we're going to put over here median, quartile 2, and median are the same thing. And then above that would be quartile 3, which see how this covers 25, 25, 25. That'd be 75% of the data. And then all the way to the end, that would be our max. So it's kind of shown here also, 25%. This should say percent on there. And so we have our minimum value, quartile 1, quartile 2, quartile 3, and then our max. And our median is quartile 2. There is not a universal agreement on calculating quartiles, and different programs often yield different results. We are going to do it in our calculator. Here are the steps. We are going to do that one var stats, and then it'll give us these values. So let's go ahead and do that. So everybody go to their calculator. If you want to clear out what's in there, you can. Or if you just want to, remember you go to stat, edit, and then we are going to put them in there. We don't have to worry about putting them in any kind of order. Okay, there's 11 values, so make sure you have all 11. You can go back through and check. Okay, I got them all. Okay, so now go to stat. We're going to calculate one variable stats. It's going to give us all that we need. So it tells us Q1. So let's go ahead and write that over here. Q1 equals 53. Then the next thing is our median, which is our quartile 2, is 57. Quartile 3 is 100. And our max is 115. Oh, we should have done min too. Min is 19, I believe. Yeah. So we're able to get all of those values. Okay, that's all we need to do on that. We're going to use this later to construct a box plot. We're not doing that right now. Okay, go to the next one. Go ahead and put this in. Find your values. Okay, so check yours with what I got down. Y'all agree? If we didn't have the calculator, we would just list them in order and then find our middle, which would be our median, and then find what's half of that on the bottom and then half of that on the top. So you don't need a calculator, but it definitely does make things a little bit easier. Okay, let's go to percentiles is our next topic. So percentile, have you ever been, y'all have taken the ACT, SAT, right? Yes, no? Some of y'all have? So whenever you take one of those tests, they rank you by percentile. So they say you are in the 60th percentile. And that means you are at or higher than 60% of your peers. So percentiles come from the data, and we are actually going to find out how percentiles are calculated. So percentiles is the measures. Oh, it measures the location by dividing a set of data into 100 groups with about 1% of the values in each group. Okay, so whenever you find the percentile, you're going to round it to the nearest whole number. Percentiles tell you the percent of data that is at or below a given value. So your certain score is, let's say, 60%. That means you are at or above 60% of your peers. Make sure the data is arranged in order from smallest to largest before finding the percentile value. So they are going to give us the data, and then they're going to say, okay, this data point is at what percent? What percentile is this data point in relation to all the data? So we have find the percentile of 90-minute intervals between eruptions of Old Faithful Geyser in Yellowstone National Park. So we want to find 90%. So we want X, this is our X value. And we want to find out how many values are less than that 90. And that'll help us find our percentile. So if we look at this, what values are less than 90? Just those two, 65 and 87. So what percent of the data is less than 90? So it'd be 2 out of 12, which that as a percent would be, let's see, well, it's 1/6, which is 17% when we round, because it's 16.6 repeating. So we'd round that, and that'd be 17%. So 90 is in the 17th percentile. 90 is in the 17th percentile. So we could call it P17. P17 equals 90. Okay, example 2. Find the percentile of age 81 for a bear based on the following sample data. So we look and see for X is going to be 81. So we want to see how many values are less than 81. All of those values. So how many does that come out to? It's 7 out of 11. We need to find out what percent that is. (64%). Whenever you divide it. Okay, so now that we know what the X value is and how to find the percentile, we are going to go the opposite way. We are going to say, what is a 64 percentile? What is the value for 64th percentile? We're going to go backwards to find out what X is. So how to convert from a given percentile to the corresponding value in the data set. So sort the data lowest to highest. Compute K over 100 equals times N, where K is the percentile and N is their number of values. Is L a whole number? If L is a whole number, then you're going to find PK by adding the Lth value and the next value and dividing by 2. If it is not a whole number, you'll just round it up to the next largest number. Seems kind of confusing at first. So let's do an example. So this is already listed in order for us. We want to find Q1. What percentile is Q1? Remember what we wrote? Q1 is anything between 0 and 25. So Q1 is the 25th percentile. So it would be, I think we write it as PK. P of K? I don't think so. Maybe not. So we're going to say K is 25 because that's the percentile. So to find it, we'll do 25 out of 100 times N, which is how many total data values are there. I think we've used this set a bunch, and it's 12. So what does that end up equaling? 3. So we need to find out what L is. So the third value, but it says if it's a whole number. So L is a whole number. Since it's a whole number, find PK by adding the L value and the next value and dividing by 2. So here is our third value, right? That would be right at our 25th percentile. But since it's a whole number, we actually have to add 90 and 92 and divide by 2. So it's actually 91. So P of 25 equals 91. That means the 25th percentile data point is 91. Remember how 90 was at 17th percentile? 91 is at the 25th percentile. Okay, quartile 2. What percent is that? It's our median, so it's 50. So we'll do 50 out of 100 times the 12, which gives us 6. So we want to know the 6th value, so that's 3, 4, 5, 6. And since it's a whole number, we have to add this one and the next one. So 93 plus 94 and divide by 2, which just means halfway between 93 and 94, 93 and a half. So that means P of 25 is 93 and a half. So we're finding it in relation to our median. So So that's actually your median. Okay, then the next one is the third quartile. So that's 75%. So we do 75 out of 100 times 12. Which is 9. So this is 6, 7, 8, 9. So that's our ninth number. So we'd say 95 plus 96 divided by 2. So 95 and a half. So P of 75 is 95 and a half. Okay, let's go to the next example. Find the 90th percentile if we take out the outlier of 65 minutes. So we have our data. They took out the outlier 65. So to find our 90th percentile, so we would do, we're finding P of 90, basically. So 90 out of 100 times how many data points there are. So now we only have 11 data points. Would be 9/10. 99 out of 10. 9.9. And what it said earlier is it a whole number? And this is a no. So you're just going to round up to the next largest whole number. So we're going to round that up to 10. So we are going to look for the 10th value. 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'd be 98. So P of 90 is 98. So 90th percentile would be at 98. Now we're going to do the 10th percentile. So P10. So that would be 10 out of 100 times 11. Okay. You end up getting 1.1. It says round up to the next one. So we're going to go to the second. So P of 10 is our second term, which would be the 90. Okay, now we just have some formulas to talk about, which would be interquartile range, IQR. I remember teaching this in 7th grade, but it's been since 7th grade since you've seen it. So IQR is interquartile range. So you take your quartile 3, you subtract quartile 1 from it. That's your interquartile range. So then an example would be, we have these quartiles right here. Let's do interquartile range. So we just subtract these. 95.5 minus 91. We end up getting 4.5. The semi-interquartile range is going to, you are going to do quartile 3 minus quartile 1, and then divide by 2. So we already found our interquartile range. So on our example, we'll just do, we already subtracted those. So this one would be 4.5 divided by 2, giving us 2 1/4. Mid quartile, this time you're going to add quartile 3 and quartile 1 and divide by 2. So we would do 95.5 plus 91 divided by 2. Add those together, divide by 2. It's basically finding the mean of those two. Halfway between them, 93 and a quarter. And then the 10, 90 percentile range, you're going to take the 90th percentile and subtract the 10th percentile from it. So we would have 98 minus 90, because those were our percentiles. So 98 minus 90 gives us 8. We are going to finish the rest of this tomorrow.